Today, we are going to talk about everything there is to know about Angular signals. What I mean by this is that, signals have happened a few months ago, first as a developer preview, now as part of the framework. And the Angular team keeps adding new APIs to these signals. And it's really a very important turn in the direction that Angular is going. And so much so that I thought it's a good idea to do a talk and explain why Angular signals in the first place, why the Angular team added these features to the framework, how it's going to change Angular in the next few months. But even right now, if you get into them right now, you can really architect your apps completely differently and start using signals right away. And yeah, we'll see what are the impacts and the benefits in terms of performance, in terms of architecture, in terms of making your Angular apps easier to maintain as well, with a learning curve that's a lot easier to get into than ever before. So just quick intro. We already did some of that. My name is Alan, or just Al. I'm based in Sacramento, California. I'm a GDE in Angular and Google Maps. I started with AngularJS a long time ago, back in 2011, and I do consulting and training at angulartraining.com. And I've been speaking at conferences all around the world, all continents but Antarctica. And yeah, always happy to be here. And as part of what I do with Angular training, I mentioned I do consulting, I do training. We also have a certification program, which is entirely made by Google developer experts in Angular. So if you're looking for a way to showcase your skills for your employer, or you're looking a new job and you want to show that you're a good Angular developer, we have 3 different certifications from that, from junior to expert. So you can check it out. And there's going to be a coupon code at the end of this talk, so you can get, a lower price on these certifications and training courses. So with that said, why signals? So the Angular team started signals with Angular 16. And the idea is that signals are the Angular that you already know, with 3 new functions, or 3 new reactive primitives that simplify your development and build faster apps by default. So the idea behind Signal is to make it easier to have reactivity everywhere, so that you write code that's reactive, meaning the user clicks on something, you get new data, and all of the components and services that are interested in that change react instantly. It simplifies change detection. It's more precise. And that's one of the things we're going to see in a few minutes. Signals are going to be a lot more precise about how to update our components. And they're also super lightweight. Signals are about 2 kilobytes of code and really fast. There is no need for a dependency, no need for third-party code. It's all included, all part of the framework, and it's as simple as it gets. So if you use the default change detection strategy in Angular today, it kind of works like this, where this is a tree of components, and if you click on a button at the very bottom of our component hierarchy, then you have Zone.js that's going to tell Angular, hey, something happened. And that something happened doesn't really tell what or where. And so Angular, by default, has no other choice but to check every single component of our hierarchy from top to bottom, right? That's a default change detection that we have in Angular right now. And it works, right? It works really well. It is performant. We use it every day, and we are quite happy with that. But the thing is, it could be better. And when we start having signals, the idea is that the hierarchy of our tree doesn't matter so much anymore. The fact that we have parent-child relationships, and historically we had that top-down approach to change detection, where you're supposed to pass data from one parent component to the child, and have that data flow down really from top to bottom. With signals, this goes away, in the sense that when a component uses a signal and changes data of its signal, then all of the other components that use that data are going to be notified. So that's what I'm representing here, where component number 1 makes a change, it's going to impact component number 2, number 3, number 4, and it's not impacting the entire tree, just the components that use that data. And not only that, not only is it just the components that are interested in that change, it's going to be the views within those components that are interested in that change. So it's really a lot more precise than just refreshing the entire app. It's not going to only be these components that display the data, but just the views. And a view is a subset of an Angular template, if you will. So if you use a for loop like ngFor or ngIf, this creates a new view in the template, which means that if you have a component that has one ngIf that relies on a signal, and the signal changes, then Angular knows that it's only this little view around the ngIf that has to be updated, and not the rest of that component. So it's really more precise than ever before, and super pinpointed to the strict minimum of changes that we have to make to the DOM are going to happen thanks to these signals. So that's really a very big thing, and it could be the #1 reason to get into signals, really, because if you strive to improve performance and change detection using onPush, for instance, and creating presentation components, and you can try as much as you want, or taking control of change detection kind of manually. You can do that, of course, but it's work. Whereas with signals, you get everything automatically, and you don't have to. The only thing you have to do is use signals, really. So, so the idea is to, other than performance and change detection improvements, several of the ideas behind signals are to simplify the approach on how to learn Angular. The concepts are as basic as possible. With signals, we only have 3 functions. And remember that if you use RxJS, last time I counted, has over 120 operators, right? So if you really want to know RxJS and Angular in depth, you would have to learn 120 operators. With signals, we have 3 functions. So kind of gives you a difference in terms of simplicity and the ease of access and getting into signals. So yeah, interoperability is always something that's important for Angular. Something I want to mention, and that was announced by the Angular team a few weeks back at ngConf, is that Angular signals are actually used in YouTube right now. So YouTube is not built on Angular, but YouTube is using Angular signals everywhere. So that's a very big step, because that YouTube is a massive web application. You're probably using it right now to watch this talk. And the fact that YouTube is now using Angular signals under the hood is really a big vote of confidence toward the technology, and a proof that it really makes a difference and it's super performant. So signals are backwards compatible and interoperable with everything we have now, meaning that there are functions to convert signals back to observables if we want to. So how to use them? Let's get into the basics of signals. And I'm going to cover all of the APIs during this talk, including the latest. And the next talk is going to be about how to do state management with NGRX signals. So we mentioned there's three reactive primitives: signal, computed, and effect. These are the three functions that we have to know about. The first one, signal, easy enough. It's a function that you call, you pass a default value to it, and it creates a signal. And what this signal does is that it can notify any piece of code that's reading that value every time the value changes. So I have a quick demo here because it's always good to look at some code. So very simple. It creates a signal with the value Angular, as you can see down here. And the idea is I have a button. And when we click on that button, I change the value of my signal. So to change the value of the signal, we have a set function on it. So I do name.setWorld to change the value of my signal to world. And then we have an expression here that just displays the value of the signal. So to read the value of a signal, we call it as a function, as a getter. And that's the basics of the API. Creating a signal with a default value, setting a new value to a signal, and displaying the current value of a signal. If you know this, you're good to go. You can start adopting signals right away. And of course, it works. So if I click on my button here, now it says hello world, because we changed the value of the signal to world. And you can see that I didn't need to change anything else in that component, didn't change the change detection, didn't change much of anything. All I did was import the signal function from Angular core, and that's it. So that's a basic signal. Now, in order to update a signal, we have two different options. The first one is set, which is the one I just showed you. You can use a set method to update the value. And if the value you're updating is derived from the current value, like a counter where you're going to increment something, then in that case, you want to use the update function. And the update function receives the current value and allows you to derive a new value for that. And again, perfect example for this is a counter. So here we have a signal with a value of 1. If we want to increment it later, we do signal.update current value, return current value plus 1. And so, yeah, now you know about how to create a signal, how to update it, and how to read its value. And that's, that can cover a lot of use cases already. And the API is already a lot simpler than dealing with, let's say, subjects or RxJS observables. The second function we have with signals is computed. And with computed, the idea is to derive a new value from a signal. So when you have a signal A that does something, and when the value of that signal A is updated, computed is going to react and create a new value out of that. So let's take a look at an example. So here we have a bunch of different signals. So I have 2 of them, a greeting, hello, and a name, which is set to Angular. So 2 different signals. And I'm combining these 2 signals into just one using computed. So computed creates a message out of the 2 signals by concatenating the greeting and the name and adding an exclamation mark. And that's it. That computed function is automatically going to derive a value when either greeting or name changes. So if greeting changes, computed gets a new value. If name changes, computed gets a new value. And we can check that because my component here, so right now it is hello Angular. That hello Angular comes from this message signal. So we can tell that it already has a value, getting the greeting from our greeting signal and getting the name from our name signal. And it computed that value, the concatenation, and displayed it. And now if I change any of these signals, so let's say I change the greeting to welcome by clicking that button, you see that my computed signal now says welcome Angular. So that's just happening. Computed automatically gets updated when any of these values change. So you can really see computed as a replacement for a lot of RxJS operators. You know, all of the things we tended to use like map, switch map, and all of these transformation, concatenation operators from RxJS, they all become computed, really, pretty much, which is a lot easier to learn. And yeah, anything you change in that function is going to be a trigger for the computed signal to update and get a new value. So it's really as easy as it gets. I really love computed. It's probably the biggest simplification to get from signals compared to RxJS operators for sure. And so yeah, I can change the text as well. So whether I change one signal or the other, you can see that it's all reactive. I click on these buttons and it works. The interesting thing about this that I can mention as well is that with this code, even if we disabled Zone.js, it would still work. So those clicks would still make Angular re-render that component. And that's because the signals, when we set a new value, they automatically mark the component as dirty. So it has to be re-rendered again. So the signals do the work already of telling Angular this component needs to be rendered, which means that for that component at least, we could get rid of Zone.js and it would work. And we'll see that it's really the direction towards which Angular is going. And we'll see what other APIs have been added recently to go fully in that direction. So that was computed. It's our function number 2. And the third one is effect. So effect is somewhat similar to computed, with the difference that it doesn't return a new value. So computed knows when a signal changes and creates a new value out of it. Effect does pretty much the same. It's going to get triggered when a dependency changes, when a signal changes, but it doesn't return a new value. It just does a background task and then completes, in a sense. So you can use that for many different scenarios. In my example, all I did with effect is a console log. So I used effect to log whenever our message changes. So I log message change to this.message, which means if I show my console and I click on any of these buttons, you can see that everything gets logged to the console. And now you know all of the basics of Angular signals. See, we can cover all of that in like 10, 15 minutes. Whereas if I had to do the same with RxJS, it would take closer to half a day to get to a point where we can be comfortable with all of these things. So that's really powerful. Signal, computed, effect, and the setup function to change the value. So one thing that is important to know about is that we have two types of signals, right? Some are writable and some are read-only. So when you create a signal with the signal function, this signal is a writable signal. You can change the value, you can set new values and everything. But if you want to expose it as a read-only version, let's say you create a signal in a service and you want to expose a read-only version of that signal, very similar to when you have an RxJS subject and you want to expose it as an observable, there's this as read-only function to do that. That's going to return a new signal that's read-only, so you can expose it and it's safe. The consumers cannot change the values anymore. And signals created with computed in effect are read-only. Meaning, of course, these ones are automatically updated based on the triggers and based on the other signals that they're consuming. So other than that, they're read-only because the logic to update is within those functions. And as a result, we cannot change that. We cannot mess with that. So what about RxJS? What does RxJS become in all of that? So in the past, we would do something like this, or maybe still in the present, right? So we create a new behavior subject, and then we set some data to it, and we expose it as an observable to make it read-only. With our signals, we can migrate easily, in a sense, by replacing the behavior subject with a signal using a default value. And then we expose our signal as read-only. And that becomes a read-only signal that other components can only read. And in here, we would do our setter to change the data of that signal. So the translation, before, that's a behavior subject. After, it's a signal, right? And so what's important to mention here is that there's the difference in terms of syntax, but there's also a big difference in terms of what you have to do with signals versus what you have to do with RxJS. And I see a few comments in the chat about cleaning things up and subscriptions. With signals, there's no subscription. You do not subscribe to a signal. You just read its value. And when a component reads a value from a signal, it's kind of registered as a dependency of that signal. So Angular knows exactly which part of your code are consuming information from that signal, right? And so so there's no subscription, there's no unsubscription. It's all taken care of internally by the framework. You don't have to worry about it. You don't have to do an ng on destroy and use all of these different strategies that we had to unsubscribe with RxJS. All of that code can go away. No more async pipe either. You can really change a lot of things and simplify your code quite a bit just by the fact that we don't have to subscribe, unsubscribe, clean things up. It's all done automatically. It's it's an Angular native feature. So it's not a dependency like RxJS, which means Angular has full control over our signals. And yeah, that's a big improvement. Still, in some places, you might still want to use observables, or you have observables that you want to convert into signals. And a common example of that is going to be the HTTP client, right? Because the HTTP client still returns an observable, and maybe you want to turn that into a signal in your code. So we can do that. There's a utility function called toSignal, and toSignal can take any observable as a param and turns it into a signal. And so the idea is that you can also pass a default value to signal, which is important because a key difference between a signal and an observable is that a signal always returns something, whereas an observable, you create it or you get access to it, and then you have to subscribe to receive something later on. With a signal, you can create it, you can code it instantly, and you would get a value. Now that value might be undefined or null if you didn't have a default value, but a signal always returns something. That's important. And so when you create a signal out of an observable, it might be better to provide a default value as a param, so that you know that your consumers always, the consumers of the value of that signal always receive something. And the opposite is true as well. You can turn a signal into an observable if you ever wanted to. So I guess this could be useful if, for legacy reasons, you have complex chains of operators that you don't want to lose, or that have complex logic that's just working and you want to keep using that. You can turn your signal into an observable temporarily to go through this and then return the value as another signal, for instance. So yeah, RxJS is still here. We can still interoperate with it. That said, in the long run, the goal of the Angular team is to really make everything, or as many things as possible, signal-based, right? And they said it on stage at NGConf a few weeks back, that the goal is to really have a future of Angular without Zone.js and RxJS. So possibly being able to do all of that without these two dependencies. Oh yeah, that's an example with a default value here. So as I mentioned, signals are synchronous, always return a value immediately, very much like a behavior subject. And so in this example, I use toSignal, pass an observable to it, and then I have my initial default value. So when you start using signals, I find that they improve readability. And I give a big block of code as an example here, which maybe is not the most convincing way of saying that this improves readability. But I have one computed, I have two computed, one toSignal. It's all one line of code every time. So instead of having, observable.pipe.operator.do something, you can do a one-liner with these computed, which really makes it a lot easier to read what's going on. And you don't have all of these operators to know about. So it does simplify and improve readability. So what becomes NGRX in all that? I'm almost going to skip those slides because it's going to be our next talk. So we have NGRX signal store, and Rainer is going to cover that just after me. So just stay tuned for what's coming up next. I'm going to skip and get to what's next for signals. So signals are officially available in v17 now. And that's important because it used to be in developer preview. Not anymore. The signal function and the computed function are out of developer preview. They're officially available. I think effect is still in dev preview for now because the Angular team wants to figure out a few more things on effect before making it officially part of the framework. But the idea, and what's going to happen really in the future, is that Zone.js is going to become optional. We'll have that localized change detection thanks to signals. The Angular APIs are going to get simplified. So wherever we had observables, it should become signals. And then the ecosystem evolves. So all of the libraries adapt to it, like NGRX started doing that. And other libraries do the same thing and start using signals more and more as an alternative to RxJS. And the main transition that's happening, and it's been the case with Angular 17, 17.1, 17.2, 17.3, is that we started seeing these APIs that are all about enabling signal-based components. So signal-based components are the future of Angular components. They're really how we are going to be able to have that signal-based change detection, where everything inside our component becomes signal-based, right? And so this is all in developer preview right now. You can use a signal as an input. You can use a signal as a model. And you can use an output function that is not a signal, but it's not an observable either. So the output has been rewritten to be independent from RxJS, because it used to be the event emitter from Angular used to be an observable. If you use the brand new function output, then it's not an observable anymore. So input looks like this. It's meant to replace the @input decorator. It comes with a few different benefits. You can specify the type of the input. So the first one, like here, first name is an input of type string, doesn't have an empty value, doesn't have a default value. So the type is really string or undefined. The second one, last name, is required. So you can do input.required of string. And as a result, the type is always string. And you would get an error if you're not passing an input last name to that component. And the last example, input of 0 is always a number because it has a default value of 0. So that's input. Something new that we get with signal-based components and didn't really exist before, or not to that extent, is the model function. And with the model function, you can create a signal that's both an input and an output. So just like ngModel in a sense, but all signal-based. So you see this example, I have first name equals name, age equals age. These two are models. So they are two-way data binding that works both as an input and an output. And I'll show you a demo of that, an example. Let's go to my other component here. So that's our component called name entry, and it uses two models. One is first name, one is age. So these are both inputs and outputs. So they are writable signals, which creates the equivalent of a two-way data binding. And so we can get the default value and we can change it. So this is loading slowly, but you get the idea. So here we have our component. So we're passing a first name of Angular, an age of 21, according to these two signals. And we have buttons in the child component that would change the value of the first name to Al and increase the age by 1. So I just keep increasing the age. And I'm doing this. So these two buttons are in the child component. They change the value in the child component. But because we have models, these are two-way bindings. So the parent component, the main component, receives those updates and displays them. So that's a two-way data binding. And that's also in developer preview. And the last one, the last of these functions is the output. So that's how you can replace. So you can replace your inputs, you can replace your outputs. All of these remove the dependencies on observables and allow you to have a signal-based approach. Even if the output is not actually using a signal under the hood, but it still has the emit function just like before. And if you ever need to turn it into an observable, there's an output to observable function. And I think there's an observable to output as well. So you can really do anything you want, right? And get feedback. Yeah, get all of these features available so you can really start using them without breaking everything. You can still have that interoperability, keep observables where you don't know yet how to remove them, or you can't. You can use those functions to to still interact with those other observables. And we also have view child, content child, view children, content children. So all of these decorators that used to be observable based, they are now signal based using functions. Same thing. So these return signals now instead of observables, and it's also in developer preview. So things are moving very quickly. The timeline is kind of like this. Future, so v17 support for inputs, outputs, and queries. We are there. Signal-based APIs have started. Fully zoneless apps, not yet, but maybe, in the near future, Angular 18, 19, maybe 20. Oh, no, 20 would be pessimist. Probably faster than that, because things are already moving quickly. But yeah, that's really where we're going. So the future is about more signals, not less. And that's everything I had for today. So I know we have a Q&A at the end. If you want to do that, we have a few minutes to get into the Q&A. I added the link to my slides, email address, my blog, all of the info. And as I promised, there's a coupon code NGLove24 to get $20 off any course of certification exam at angulartraining.com.
Thank you, Rainer, for this great presentation and for the code for our community. And as you have mentioned, we'll start with the Q&A because there are already some questions. So let me bring them on. So first from Mayank, how to decide between RxJS and Signals?
That's a very good question. I would say you, in the current state of things, I would only use RxJS if I don't have any other option. So you're using HTTP client, the HTTP client returns an observable, you have to deal with that. But everywhere else, if you're creating something new and you're thinking RxJS or Signals, I would say go with Signals. So start using them as much as possible, because again, the Angular team is thinking about this future where everything is signal-based. So if you're writing new code that goes in an RxJS direction, it might be something you would have to update later on and migrate. So that's why I would say Signals first, RxJS second. That's really the mindset. And that's how I would decide. So you can do the same.
Yeah. Okay. Let me bring another question from Adam. How to integrate Signals with reactive forms? What's the best practice to react to status change, value changes of form controls using Signals?
Yeah, so that's one of the APIs that's work in progress in the Angular team, making everything signal-based. So this is going to happen for these observables as well from reactive forms. For now, you can use the toSignal function if you want, right? So if you really want to start using signals with reactive forms, you would just use toSignal on that status changes or value changes, and then you get a signal out of it. So you can definitely do that if you want to, but it's kind of a work in progress right now. We're really in an in-between situation with reactive forms, so it's not ideal yet, but it's going to happen.
Okay. There is also a question from Hamed. What is the difference between computed and effect?
So computed returns a value and effect doesn't.
Okay.
So computed returns a new signal with a new value that's computed from any number of other signals, right? Where effect doesn't return anything. Effect is just a way to say, when this signal changes, do that other task, do that side effect.
Okay. There is another question from John. Can you elaborate on the concept of view that you have mentioned, the idea of structural directives like ngIf creates a view inside the template, for example?
Yeah, so a view, and I think the Angular team writes it really well in the documentation of the framework. They say that the view is the smallest set of instructions that Angular needs to update a part of the DOM in our components. So the compiler is basically creating those views, creating these instructions that update the DOM. And when we use structural directives, we create views in the compiler that knows how to update those subsections of our templates, in a sense. So when you use an ng container, ng template, router outlets, I guess all of these things create views, in a sense. So they create a part of our component that's dynamic, that can change over time, and that the compiler has specific instructions from. So that would be the way to visualize what a view is, really. But yeah, and we don't really have to know about it as Angular developers, right? You can write Angular code without ever knowing about these views. They just become important in the sense that signals are going to be able to update individual views rather than components. So they make change detection extremely precise compared to what we had before.
Okay. There is another question from Florin. Some of the questions which were already answered by the community, I just skipped because there is like a lot of them and wouldn't be able to ask all of them. So when Angular will be ready to not require Zone and JS anymore, we will be forced to update all the RxJS code to use signals if we want to our app continue working.
Okay, so when Angular will be ready to not require Zone.js anymore, there is no official date on that, but I would bet for Angular 18 or 19, I would say. It seems pretty close. So, by the end of this year, I think it might happen. But again, it's just my prediction, right? There's no there's no official date. So it's just me predicting. Will we be forced to update all our RxJS code to use signals if we want our app to continue working? No, you don't have to do that. You can still use RxJS now and in the future. Removing Zone.js and removing RxJS is going to be optional in the foreseeable future. So you don't have to migrate everything if you don't want to, or if you cannot. It's just going to become optional. That's the idea.
Okay, so I will just choose two more questions. How to update the value of signal when another signal will change his value?
So update the value of a signal when another signal will change its value. The idea is to computed is really what we need for that. So computed is the function that takes a signal or two or three and derives a new value out of it, right? Mm-hmm. In some cases, you might use effect to do it, but if you try to update a signal within effect, you'll get an error by default. You get a warning from the Angular compiler that says, oops, you should not do that, because it's typically dangerous and can create, infinite loops of updating stuff. So Angular would warn you if you try to do things that it doesn't like. But yeah, computed is what we should be using. Effect can kind of do that work, but not recommended typically.
Mm-hmm. Yeah. Okay. There is another question from Marcus. Can you explain Untracked a bit in detail?
Can you explain Untracked a little bit in detail? So Untracked, I've not used it that much, so I won't go into too much details into it. But the official definition for it is that it would prevent unnecessary dependencies to reevaluate any computed effect that depends on a value when it changes. Which is, we would have to go a little bit too much under the hood with the time that we have left to get into Untracked.
Okay, so let me bring the last one, like any fluffs of signals.
Well, I guess the best answer to that is that signals come from Angular, and they are used in YouTube, which is used by millions of people every day. So if there was any flaw or anything obviously wrong with them, I don't think Google would have done that, right? And start using signals on probably their biggest product that's used on all mobile devices, website, and everything every day. So yeah, that's my answer. If there was anything wrong with signals, I don't think they would be more and more popular and used all over the place, and that Angular would bet pretty much everything on them.
Yeah. Okay, so that was the last question. So Alan, thank you for your time. It's been like absolute pleasure having you as a speaker. Your presentation was very informative, and we hope to see you again in our future meetups.
Yeah, no problem. Thank you for having me.